Hey there, welcome to this explainer. If you really stop and look closely at the natural world around you, you're going to notice a pretty massive mystery hiding right in plain sight. Nature has an absolute obsession with the hexagon. Not squares, definitely not perfect circles, but that classic six-sided shape. Today, we're going to unpack exactly why that is. So from tiny honeycombs to literal storms on Saturn, why is nature so completely obsessed with the number 6? Let's put on our detective hats here, because once you start looking for this shape, I promise you, you literally see it everywhere. And nature isn't just doodling for the fun of it, right? There is a really profound, fundamental logic driving this pattern. We can call our first major clue the micro to macro mystery, because this whole six-sided phenomenon, it's not just some local earthly coincidence. I mean, just look at these examples. On a massive macro scale, Saturn's northern pole has this persistent hexagonal cloud pattern, and this thing is gigantic. The sides are about 14,500 kilometers long. To put that into perspective, that is wider than our entire planet, with jet streams whipping around at 320 kilometers per hour. But then you come down to Earth, and you see the exact same shape and geology. Think of the Giant's Causeway in Ireland, where rapidly cooling lava contracted and cracked into these perfect hexagonal basalt columns. You see it in biology on a turtle's shell, and even way down at the microscopic level in the crystalline structure of a snowflake. It's wild, the exact same blueprint, just endlessly repeating across totally different environments. To really get why this happens, we have to talk about the flawless math of efficiency. Let's look at the actual mathematical evidence. Ask yourself, why not squares or circles? Well, if you try to pack circles together on a flat surface, you're going to leave all these empty, wasted gaps. Squares and triangles, sure, they pack together perfectly, which is a concept we call tessellation, but they require a ton of perimeter material to enclose the space. When you compare them all side by side, hexagons are the absolute undeniable mathematical winners. They tessellate perfectly without any gaps whatsoever, and they use the absolute bare minimum amount of material to enclose a specific area. Basically, it's the ultimate shape for storing the maximum amount of volume using the least amount of material. This mathematical truth is actually known as the honeycomb theorem, and human beings have suspected this for a really long time. The Roman scholar Marcus Terentius Varro first wrote about this honeycomb conjecture way back in 36 BC. But get this, it actually took mathematicians over 2,000 years to formally prove what nature already just knew. It wasn't until 1999 that mathematician Thomas C. Hales finally published the complete proof, showing that yes, the hexagon is absolutely the ultimate geometry for spatial efficiency. The real magic number behind all that math is 120 degrees. When three walls meet at exactly 120 degrees, they create the most mechanically stable junction you can possibly get. All the forces pulling in different directions are perfectly balanced. It's exactly the kind of structural trick a master architect would use to keep a building standing, but nature just does it automatically. Which brings us to soap bubbles and physics. If you want to see this math turn effortlessly into reality, we really don't need to look any further than a simple soap bubble. You see, the universe doesn't need a calculator to find that perfect 120-degree angle. It relies on surface tension. This acts like a mindless, incredibly efficient physical law. Honestly, nature is kind of a cheapskate when it comes to energy. In a bubble, the molecules pull together, shrinking the whole thing until the inward pull perfectly balances the outward push of the air inside. It naturally, almost lazily, adopts the shape with the least possible surface area, a perfect sphere. But here's where it gets really cool. Watch what happens when we force a bunch of those bubbles together on a flat surface to create a bubble raft. On their own, they float as spheres. But the second equal-sized bubbles bump into each other and share walls, surface tension instantly forces those intersections to rearrange. And guess what angle they form? Exactly 120 degrees. It instantly self-organizes into perfect hexagonal rafts. There's no brain involved, no master blueprint, just pure physics finding the most stable, efficient shape. And that brings us to the core debate of this explainer. Bees, instinct, or physics? For centuries, people looked at honeycombs and just marveled at the genius of bees. Even Charles Darwin was completely blown away. Back in 1852, he said the honeycomb was absolutely perfect in economizing labor and wax. He honestly believed that over millions of years, evolution had turned bees into these tiny, instinctual master mathematicians, carefully measuring out perfect 120-degree angles. Well, actually, here is the brilliant reality of it. It's a stunning partnership between biology and physics. The bee's biological instinct isn't geometry.
It's simply building round tubes of wax, and then using their little bodies to heat that wax up to exactly 33.6 to 37.6 degrees Celsius. At that sweet spot, the wax basically acts like a liquid. And just like with our soap bubbles, surface tension takes the wheel. It effortlessly pulls those soft wax walls into that mechanically stable 120-degree hexagon. So bees aren't crunching geometry in their heads. They just bring the heat and the raw materials, and the physics of surface tension swoops in to do the perfect mathematical finishing work. How cool is that?
But hey, this elegant little partnership doesn't just apply to beeswax. Let's look at fly eyes and oceans.
Nature takes this exact same efficiency hack and scales it across all sorts of living organisms. Take a fly's compound eye. It uses hexagonal facets to catch the maximum amount of light while using the absolute bare minimum of cell material. Deep inside each facet, called an ommatidium, 4 cone cells cluster together exactly like 4 soap bubbles. And if we dive down into the ocean, marine creatures like radiolarians build these incredibly delicate, super strong exoskeletons out of hexagonal meshes. Sea urchins and sponges even use soft hexagonal membranes as biological molds to cast their hard mineral armor. Whether it's catching light in the air or building armor underwater, nature just can't get enough of this blueprint.
Looking at how this breaks down, it proves one really big point. The building blocks themselves really don't matter. Whether you're working with fragile soap film, warm beeswax, biological pigment cells, or literal hard ocean minerals, the universal law of efficiency is always running the show, driving the final design straight toward the hexagon. And that reveals the secret of universal design. The biggest takeaway here is that the number 6 isn't just some random pattern nature thought looked pretty. It is the physical and mathematical signature of a universe that is constantly striving for perfect balance. It's literal proof of energy being conserved and space being completely optimized.
So the next time you're out walking around, I want you to consider this. If mindless physical laws can partner with biology to engineer something as spectacularly beautiful and precise as a honeycomb or a fly's eye, what other brilliant secrets are just waiting for us to discover? What other hidden geometries are silently shaping the world right under our noses? Thanks for hanging out with me for this explainer. Keep your eyes open, guys. You're going to start seeing hexagons absolutely everywhere.